Happy Thursday to everybody. I hope that you all have had a great week. Now that we are done with arithmetic sequences and series and geometric sequences and series, today we're going to move into something that should be just like breathing. We are going to talk about linear functions, and we're going to talk about graphing linear functions and slope-intercept form and writing equations of a line given a graph and all of those fun things. So we kind of have a lot to go over, but it's not going to be that bad. I do only have 15 minutes, so I'm going to do several examples. I'm going to try to do definitely an example of each type of question, and then you guys are going to have some problems to practice. Please keep in mind that you need to hold on to these practice worksheets because I will be checking them for a grade when I get back on Tuesday. So first, let's talk linear functions. We've discussed functions over and over and over and over, and when we first discuss any type of function, that's really bad. We normally talk about our function machine, and we talk about how we have an input, which is normally our x, and we have an output, which is our y. Now when we set ourselves up with an input and an output, our linear functions, you see that they always increase at a steady rate. They have a constant rate. Anything that's a linear function is going to have some kind of relationship of add 3, multiply by 2, add 4 and add 4 and subtract 6. Those are all different types of linear functions. We are going to do something to the x in order to get our y. So just a quick something, if we say multiply by 2, then I can input anything at all. I can input a 1, and that will give me 1 times 2, which is 2. I can input a 2. 2 times 2 gives me 4. I can input a 3. 3 times 2 gives me 6. I can input a 0. 0 times 2 gives me 0. I can input a negative 1. And negative 1 times 2 gives me negative 2. What makes something linear, and sorry for my huge graph, is that if I were to graph these points over 1 up 2, over 2 up 4, over 3 up 6, 0, 0, and negative 1, negative 2, we form a line. And all of you should remember that linear functions are in the form of y equals mx plus b. When we have something in the form of y equals mx plus b, where m and b are two constants or two integers, or even two rational numbers, because we could have a fraction or a decimal as our slope or as our y-intercept, then we have a linear function. So the first part of your practice is going to ask you if we have a linear function or not. And obviously if they are in the form of y equals mx plus b, that is a linear function. Some things that are not linear functions are quadratic. So if we get into the form of y equals x squared, that is not linear. That's going to be our parabola. If we get in the form of y equals x to the third, that's cubic and our funky s. We can get into the form of y equals 1 over x, and that's our rational functions, where we're going to do this kind of stuff. We can get into the form of y equals a to the x, which is going to be exponential. And we've just learned so many different functions, it's not even funny. We even have the sine of x, right? We have our periodic function. And those are also not linear. So, if it can't be put into the form of y equals mx plus b, you're good. Some of the things that we know about linear functions, if we have y equals mx plus b, this is our slope-intercept form. It's my favorite. I love slope-intercept form. It's obviously the most useful. To me, it's the most useful. You can automatically see where your slope is, and you can automatically see your y-intercept. So I'm a big fan. Another way we represent linear functions is ax plus by equals c. And this is our standard form. Now, I know Miss Little said she is a big fan of standard form for some particular reasons, and we're going to look at that in just a second. Standard form is, it's how we see things written a whole lot, and before I graph them, I tend to put them in y equals mx plus b form. But there is another way we're going to look at here in a second that we can look at standard form, and it can be useful. But I'm still going to stick with I'm a slope-intercept girl. Our coefficients a, or we're going to have a coefficient against the x, which is always going to be the a. What's in front of the y is b, and then our constant on this side is our c. I can give you an equation such as 2x plus 3y equals 6 that's in slope-intercept, or pardon me, that's in standard, and I want to convert it to slope-intercept. In order to convert this to slope-intercept, that means we're going to get our y by ourselves. We're going to isolate this y. And we've been doing this for years. We subtract 2x from both sides. We get 3y equals negative 2x plus 6. We divide both sides by 3. And we get y equals negative 2/3 x plus 2. So this right here is automatically going to tell me my slope is negative 2/3, and it is also going to tell me that my y-intercept is 2. So useful for graphing. Obviously, if you wanted to graph, use my huge graph again. I'm going to come right here. If I want to graph the line, I'm going to put my y-intercept at 2. And then using my slope, since it's negative, I go down to right 3, down to right 3, down to right 3. And hopefully you get a beautiful line out of that. So we should be able to graph using our slope-intercept form. I can give you something in slope-intercept form and ask you to put it in standard form. If I were to give you y equals 1/3 x minus 5 and ask you to put it in standard form, then that means you're going to have to move this negative 1/3 x to the other side, or make it negative 1/3 x. So now that cancels out. We have negative 1/3 x plus y is equal to negative 5. I don't like the negative 1/3 x. It just depends on some teachers. It depends on some books. Some people say that if it's in standard form, it can't be negative. Your a can't be negative, and your a has to be a whole number, or an integer, pardon me. But actually it would be a whole number, because you would never have a a negative. If you want to get rid of the negative and you want to get rid of the 1/3, we can multiply everything by -3. That negative times a negative is going to give me a positive. 3 times the 1/3 is going to get rid of that fraction. And I'm going to use my distributive property, remembering that if I multiply the first term by -3, I have to multiply all three. Negative times a negative is a positive. Once again, that gives me x. And then it becomes minus 3y equals 15. Hopefully that makes sense to everybody. So going back and forth between slope-intercept and standard form, you are going to be asked to write a few things in standard form. And so if we are writing in standard form, we're going to say today that A has to be positive and A has to be a whole number, which actually is repetitive, because if it's a whole number, it is positive. So no negatives, no fractions. Get rid of those fractions. Now, we have to talk about graphing in a little different way. Earlier I gave you all the equation 2x plus 3y equals 6. So if we look at that again, 2x plus 3y equals 6. You can use this to graph with your x and y intercepts. Now, if we think about it, every single point on my x-axis has a number, comma, 0. This is going to be 1, 0, 2, 0, 3, 0. This is going to be 0, 1, 0, 2, 0, 3. So we have 0, a number on our y-axis. So if you want to find your y-intercept, you can plug in a 0 for x. So we get 2 times 0 plus 3y equals 6. So the 0 cancels out, you divide both sides by 3, and that automatically tells you that y equals 2. So my y-intercept for this line is going to be 0, 2. 0, 2. If I want to find my x-intercept, we're going to have a 0 for y. So we will start with 2x plus 3y equals 6. And we have 2x plus 3 times 0 equals 6. So that gives me 2x equals 6. Divide by 2, and x equals 3. So 3, 0 is my x-intercept. And we can draw a line that way as well. So you should be able to tell me, if you're in standard form, what my x-intercept is and what my y-intercept is. Let me label these. This is going to be my x-intercept. Pardon me, wrong color. Oops. Pardon me, wrong pen. X-intercept. And if we have 0 in a number, that is our y-intercept. Now I have one more quick thing that I'd like to go over, which is not anything big. In fact, I'm just going to use one of the problems that is on your paper. It gives you 2 points, 0, -3, and 2, 1. So this is 0, -3, and 2, 1. If we have this line, how can we write the equation? Well, I can see very clearly that my y-intercept, or my b, is -3. And to find my slope, it's going to be my rise, which is 1, 2, 3, 4. So slope is equal to 4 over my run, which is 2. So my slope is 2, and I get y equals 2x minus 3.